Hi everyone, welcome to the very first Teach Kelvin Your Thing session. And in this very first session, I'm having Luciano over. So, Luciano, may we meet you?
Hello, everyone. My name is Luciano. I am a senior architect for a company called Four Theorem, and I am the co-author of a book called Node.js Design Patterns that I'm going to be showing you here just for promotion, right? Thank you, Kelvin, for the promotional space. Yeah, what else? Yeah, that's me. Thank you for having me.
Awesome. So, what are you going to be teaching me today, Luciano?
Yeah, one argument that I've been, one topic that I've been discussing about lately has been iteration protocols in JavaScript. And iteration protocols is basically the things that leaves behind when you do for await, for instance, to get all the elements of an array, but also when you do for await of and you consume asynchronous data in sequence. So if it doesn't make any sense right now, we are going to go through examples, but basically it's just a nice way, for instance, to actually one example that we are going to be seeing at the end is to go through a paginated API. So for instance, you get data from the first page and then you need to get more data. You're going to query another page. So basically, we are going to see how this JavaScript functionality allows us to do that in a nice and easy way.
Awesome. So, I think the floor is all yours, and I'm your student. So, take it away.
Okay, let me try to share my screen. I think you might have to allow me to do that.
True. Okay. I think, yeah, you're good.
Okay, so let's try again. You should see my console.
Yeah.
And also I should have a Visual Studio Code project. Okay, but I think we can get started with just running something in the Node.js console, right? So the basic idea is let's create an array first. Let's call it IRR, and let's say Kelvin, Luciano, and I don't know, who, bar. I don't have a lot of imagination today.
No problem.
So the interesting thing is that in JavaScript, an array is something that is called iterable, which basically means that you can, as an object, it contains a number of values inside, and we can have different ways to get all the values from that object. In this case, it's an array, so basically the values are all the strings we put in the array, right? So one thing that we can do is basically do a for, like what would you generally do if you want to do a for loop over an array? Actually, let's start it this way.
Well, you have a couple of options, so I guess we could do the for each, like the array for each.
Basically, you will do array dot for each, and then you say, I don't know, v and console log, the value is nb, something like that, right?
Yeah.
Yeah, so that's definitely one option. How many other options can you think?
Yeah, I think for off, right? Like, but you need like an index, the I, so we gotta use the I variable most of the time. So for in, and yeah, I think we have that.
Yeah, so for instance, you will do the regular for loop, something like, I don't know, that I equals 0, and then I minus r dot length, and then I plus plus. And now we have value equal basically array I, let's say that. And then we can do, for instance, console log value. And that should give us all the values, yeah. Then we also have for in, right?
Yeah.
Which is interesting as well. So we can do for, let's say, let I, because that will be the index in array, and we do console log of I. And I want to do this because it's interesting to see that for in only gives you the indices and not the values. So if you want to get the value, you need to do this.
I did not know that.
Okay, now this is actually a very interesting one, because the point where I want to get to is, instead, rather than using the for in, we can use something very similar that is called for of. And it basically looks exactly like this. We just need to change in with of. And this time we get v because we get all the values.
Cool.
And the reason why we can do that is because there are many ways that you can do iterations in JavaScript, as we have seen here. I actually did a little game in a conference yesterday, and we found out 28 different ways of doing all sorts of types of loops over objects and arrays and streams, and yeah, so there are many ways, and it's a little bit confusing sometimes. What should you use? The good news is that there are now these iteration protocols, the things we're going to discuss today, that are trying to find like a standard and allowing you specific capabilities like doing for of or using the spread operator, but then also they allow you to implement your own custom objects that can be iterable. So for instance, if we create a new data structure, maybe we want to create, I don't know, a binary tree, because for some reason we want to use that. In a binary tree we have nodes, and if we want to list all the nodes in the tree, we can make that tree iterable, and then we could be using for of on that tree. That's, for instance, an example. But even more interesting is that we can also do asynchronous iteration. So we can also use for await with these protocols, which is even more interesting when you have to get data from, I don't know, some remote location like a database or an API or even the file system, and you need to process that data in order. So does that make sense?
Yeah, so far I'm following you, so I'm good.
Perfect. Okay, so I want to start by describing, actually, let's think about an example, right, that we want to build. I'm gonna try to do a sketch here. I'm gonna call this countdown.js. Let me make this a little bit bigger. So basically we want to build a custom object, and we're going to have a function called create countdown, right? And in this function we give a number, like, I don't know, let's say that the number is n, and we want to have a way that if we create an object with this function, we can do a for of on that object, and that object will give us all the numbers from n to 0. So for instance, if we say something like this, countdown equal create countdown from 5, then what we want to do is for let num of countdown console log, and basically we want to see 5, 4, 3, 2, 1, 0, right?
Yeah.
So how can we make this happen? We need to implement this protocol. So here we can return an object. For now we can just return an empty object. What we can do is implement the Iterator and Iterable protocol, which I'm going to describe in a second, that will make this object suitable for doing a for of. So JavaScript will be able to understand that this specific object is something that contains values, and it will allow us to do a for of on that object. So the first protocol that I want to describe to you is the Iterator protocol, which basically says that an object, in order to be considered an iterator, it needs to implement only one method that is called next. So here we are creating a new object, and we want this object to have a function called next. And this function needs to return a specific type of response. Every time we call this function, it needs to give us an object, and that object needs to contain two values. The first value is done, and this is a Boolean. So for instance, let's say true, or actually let's say false. And the other one is value, which is the current value of the iteration. So for instance, at the beginning, this could be n. Right? So if we do this, what is going to happen is that, so the idea here is basically, with this .next method, we can get elements out of the object, in this case, out of the iterator. So every time we call next, we are going to get the next number in this sequence. Now, it doesn't have to be numbers. We will see later on that can be more complicated object types. But the idea is that we have a sequence and we want to get the next element in the sequence. Another example, now this is a countdown. So the idea is that we give it a starting number and it will always give us that number -1. Then next number will be -1 until we get to 0. So if we start from 5, the first element will be 5, then 4, then 3, then 2, 1, and 0. Other examples, for instance, could be, I don't know, the Fibonacci sequence. You could implement an iterator that every time you say next will give you the next number in the sequence, right? Yeah. Or again, if we were building a tree, you could get the next node in the tree, something like that. So you are free to implement this protocol as you want. Value can be any type of object supported by JavaScript. Okay, but of course this implementation is not complete, right? This is just a placeholder. Now we need to add a little bit of business logic. And the business logic is that we can say start or maybe current is equal to n, which is going to be the current value, like what is the next value that we are going to have to return when somebody is calling next. And here what we want to do is if current is lower than 0, then it means that we finish our iteration. So we just need to return done equal true. But if we are not finished, what we need to return is basically current minus minus.
All right.
Why doesn't like that? Oh, because it's constant. So basically at this point, what we are saying, we cannot do this yet. So I'm going to comment this one out for a second. But what we can do is something like this. We could say console log countdown.next and do this a number of times, right? And we want to see what happens. Do you want to take a guess what happens the first time? What do we see?
Okay. Well, okay, minus. I guess we're gonna have 5. And 4.
Okay, let's run this code and let's see what happens. So let me make this a little bit bigger. So what did we call this one? Countdown.js. Okay, so every time we call next, what we get back is an object with the structure that we defined. So there is always a flag that is a Boolean that is saying us, is this finished? Yes or no? And here is saying, it's not finished, the current value is 5. The next time we call next is saying, is it finished? No, the value is 4, and so on until we get to 0. We can still call .next as many times as we want, but we are never going to get more values. We are only going to get done true.
Interesting.
Make sense?
Perfect sense.
Okay, this is not super useful, right? Because of course it's annoying that you need to call next. We also, like, if we want to do a proper loop, we need to check if that value done is true, and then build a loop in that way, maybe doing, I don't know, a while done is not true, keep going, and yeah, it can be a little bit complicated. So we can see this as a building block, but we need to do a little bit more in order to be able to do this for loop. Now what I want to do is remove all of that and try to enable this for loop. And try to run this code again and see what happens. Now, if we run this, it fails, and the error message is actually really interesting. So it's telling us this object countdown that you are trying to use the for of syntax on is not iterable. But we said, okay, we implemented one protocol that is called Iterator. It's a way to get the value, the next value, right? Instead, the iterable protocol is more, you have a generic object and you can get an iterator from that object. So you can imagine the iterator as an arrow, something that gives you the next element, and the iterable as a complex object that you can get an arrow to get all the elements one by one, if that makes any sense.
Yeah, it makes perfect sense.
Okay, so how do we make this object now an iterable? So it is actually, once you have an iterator, it is actually quite simple. You have to implement a special method that is called symbol.iterator. And this needs to return, so this one is a function without arguments, and this one needs to return an object that is an iterator. So basically what we want to do is return this. Let's see if I'm doing this correctly, and then we'll explain it better because it might be a little bit complicated. Okay. And actually the other thing that we want to do is to put this code here, because every time we get a new iterator, we want to restart from the original number. So if we created a countdown that starts from 5, every time we do a for off, we want to start again from 5 to 0. Okay, let's see if this works first, and then we'll rediscuss what we did. Okay, good. It did what we expected. So 5, 4, 3, 2, 1, 0. So let's review what we did. We try to do an iterator. Then we try to use a for off over that iterator. And JavaScript told us, sorry, you cannot do a for off because I was expecting an iterable, not the object you gave me. That's not an iterable. So we try to say, okay, how can we make the countdown iterable? And there is this iterable protocol that says if an object has this special function called symbol.iterator, that makes the object an iterable, because it means from this object there is a way to get an iterator out of it. Okay? And basically the iterator is the same code that we wrote before. So we said an iterator is just something you call next on top of it, so there is a next function, and you can keep calling it and get to the end of it when you see done equal true. Any question on that? Is it confusing?
No, it's quite simple. So I think the only thing we needed to make it an iterator is to have this special symbol.iterator function wrapping our already implemented next method, right?
Mm-hmm. Exactly. Yeah. So generally you start from an iterator, and then to make it iterable, you just need to create this function here with this special name, and that will return the iterator you created before.
Okay, perfect.
Now, another interesting thing is that we can create an object that is both an iterator and an iterable at the same time. And it's a little bit of an hack, but it's probably, in some cases when you can do that, it's easier. Like you have the freedom to use that object either by just calling .next manually if you want to, maybe because you want to consume only few elements and not all of them. But if you want to consume all the elements, you can do a for of, right? So it could be convenient sometimes to make an object both an iterator and an iterable. Let's see if we manage to do that. And to do that, we need to do a little bit of shuffling around. So we want to do, so basically this one needs to return an iterator. And if we want to make the same object an iterator, then we just need to return this, right? So it's saying, I am already an iterator. So if you want to know which iterator should you use, just myself, right?
Yeah.
And here, what we need to do is to do, we need to do this. And this one needs to have a next. And a comma here, yeah. I think this one should work. So basically we are saying we are returning an object that is an iterator because it has a next method. But it is also an iterable because it has this special method that returns an iterator, so itself. Make sense?
Makes sense. So, yeah.
One thing that we should do, just to be super careful, is to always reset the current value every time you try to get a new iterator. Okay, so let's see if this still works. I'm not 100% sure. Let's see if we did everything correctly. So it still works as a iterable because we are using for of. But what if we want to do, before doing the for of, we want to do countdown dot next. We do console log of that. What do you expect is going to happen?
Yeah, we should have 5 first. Yeah,
exactly.
Yeah, the objects with the flag and the value.
Perfect. I think that's the right answer. We'll see in a second.
Okay.
But then, do you expect that here we start to see 5, 4, 3, 2, 1, 0, or we see it from 4?
Well, since I think you should see it from 4, since you're always setting the current value at the iterator method. Could be.
Let's check that out. Okay. I'm not 100% sure. I think we'll see 5 as well again, but let's see if that's true, and then we'll try to figure out why. Okay, so yeah, first we done false 5, and that's the first console log that we do with the dot next, and then this is all we do with the for of. Okay. Now the reason why we see 5 again is because here, so when we do the for of, what JavaScript is going to do is going to check, is this object countdown an iterable? So it's going to check, does it implement this function? And it does. And at that point, it's going to execute that function. So this function is executed, and what we're doing here is resetting the current. Now, if we comment this line, I think your answer is the correct one. So we should see 5 only once.
Yeah.
Okay? And if we do another loop after this, it should never do this other loop because it's already exhausted, basically. So we should see the loop only once. Now, the best practice is that every time you want to do a for loop, like this actually depends, because sometimes you are implementing data structure that when you consume the data is not available anymore. Like you cannot go back, you cannot reset. But when you can reset, sometimes it makes sense to assume that every time somebody is doing a for of, they want to start from the beginning to the end. So it's kind of a best practice to do this, in my opinion.
Okay.
So now if we do this, we should see the 2 times that, like this is the first for of, and this is the second for of.
Got it. So it's always resets.
Mm-hmm.
Okay. Got it.
Okay, so this is kind of interesting example, but there is an interesting alternative to this, because this syntax is not too complicated, but it's like if you are building something more complex, like here we are only doing a countdown. If you start to think something like a Fibonacci, where you need to keep the previous two numbers and the next number is the sum of the previous two numbers, right? So you have a little bit more state, a little bit more logic. If you want to do it this way, it starts to become a little bit more complicated because there is a lot of boilerplate, let's say, just to make it iterable and just to make it an iterator, right? So there is actually a nice syntactic sugar. Did you ever use generator functions?
Nah.
Okay, so that's actually a nice topic.
Okay.
Let's do a new file and let's say gen.js. So basically a generator function is a special function where you put an asterisk here and then the name, let's say hello. And when you say this asterisk, this function becomes a little bit special. It kind of has a new superpower. And the superpower is that you can use this keyword called yield. And for instance, we can say hello, right? And now when you do this, what you can do is, let's say h equal hello. This will give you an object. So let's try to see what this object looks like first. What did we call it? Gen.
Yeah, gen.js.
So it's saying, okay, this is just an object and the object is a generator. Now, a generator is both an iterator and an iterable. So if we do h.next, what do you expect to see?
Yield. The value of yield should be hello.
Okay, yes. So let's see if that's the case. We see value hello, done, false.
Oh, I see.
So basically what yield does, actually before doing that, let's do another next. And what we get is the first time hello, the second time undefined, and done true. We can do another yield here, and we can say world, for instance. So if we do this thing again, it's going to do hello world, and if we add another next, it's going to do hello world, and then undefined because as completed. So what yield does is actually really interesting. It's kind of a return, but it's a little bit more special than a return because it's going to remember the point where the last yield was done. So if you call next again, so the first time it's going to stop here and give you hello. The second time it's going to start from here, go to the next line, it's going to find another yield, and it's going to give you this other value. The third time that we call it is going to get to the end and it's going to say, okay, there is no more value, so we are done here. This iteration is complete. So basically, yield is kind of an interesting way that allows you to stop the execution, give you a value, then the next time you are calling it is going to resume that execution from that point and it's going to continue. The interesting bit is that we can have variables here. So we can say let, so we can convert this into our countdown, right? So we can say num, and we can say current. Actually, what we can do is for I equal num, sorry, let I equal num, I bigger than 0, and I minus minus, we can do yield of I. And now what we want to do is count down, let's call it count, let's call it, actually, sorry, let's call this create countdown. So we have the same syntax as before. And this is create countdown. And now h dot becomes countdown next. So this, I think, should explain a little bit better the idea of yield, because now we have a little bit of state in our function. So there is this I that initially is going to be whatever number we are giving here. And then every time we go through a loop, an iteration of the loop, this value is going to decrease by 1. So if we initially have 5, the first time we find yield is going to give us 5, and then it's going to stop there. If we call the function again, it's going to remember, by the way, the value of I is 5, and you are here. So if you continue, you are going to do another loop, another iteration of this loop, and the value is going to become 4. So it's interesting that a generator remembers the state that it was in the last time that it was yielding a value. So when you call it again, it can resume, and it gives you a very nice syntax to do all the stuff that basically we did here in 17 lines. Now we are doing it in 5 lines. Does it make sense?
Yes, let's show that.
Let's see if it works first. It's not working, so what did we do wrong? Let's see what are we doing wrong. Oh, yeah, sorry, I didn't pass any value, so we need to say 5.
Yeah, sure. I could have got that.
It's still not working, so we are probably doing something else wrong.
I less than 0. Okay.
Oh, yeah.
Yeah.
This should be bigger than 0, right?
Yes.
It's telling us that it was done straight away, so it did essentially skip all the loop and completed the function. So if we run it now, let's see if we, okay. Now it's doing 5, 4, and 3, just because we did this only 3 times. Of course, if we do it a couple more times, it's going to go to 1, so we need to do other 2 times. And now we have 5, 4, 3, 2, 1. Oh, 0 is already skipping it. We need to do equal 0 if we also want the 0. Yeah, that makes sense. Any questions or comments there?
Well, it seems like internally the generator and the yield keyword is kind of implementing the iterator's signature you showed in the beginning, where you have an object with a value and the done flag. So is it safe to say that internally the generator do implement the iterator protocol?
Yeah, that's 100% correct. And what's more interesting is that it also implements the iterable protocol. So everything we did here, we can easily just convert to a for of const val of down, if I can spell, and say console log. Why did I put the off here? Sorry, of val. And now we should see just 5, 4, 3, 2, 1, 0.
Wow.
So basically, we literally implemented everything we did here in 17 lines in just 5 lines. So this is the power of generators. So it's kind of a nice syntactic sugar for creating both iterators and iterable objects.
Cool. And I dare to say that this is actually the first time I'm looking up closely at generators. It's one of those ESCs features I just keep away for a while because I don't use them personally, but I'm learning a lot about it and it seems cool, especially when you want to implement your own custom iterable objects and things like that. Very nice.
Yeah. So yeah, I suppose this is kind of the basic ground when we are talking about iterator protocols for the synchronous version. So here we are never doing anything asynchronous, like, I don't know, calling an API or reading a file from the file system, connecting to a database. But what if we want to do one of these things and still do an iteration? And I don't know, an example that I dealt with recently is if you want to list all the files in an S3 bucket, for instance, S3, if you have many files, will give you like a paginated API. So the first time you request the list, it's going to give you the first page, maybe 50 elements. Then you need to request for the second page, other 50 elements until you process all the pages, right? Similarly, if you want to list all the tables in DynamoDB, very similar API. And one, actually, I have two examples that I want to show you. I don't know if you have ever seen this beautiful API, the Ricky Morty API.
No.
So it's actually really cool. So do you know Rick Morty, the cartoon?
Nope. I will go watch that.
Okay, I'm actually not an expert of it as well. I've just watched few episodes. So
Okay.
there is another one we can use, which is the Star Wars API. Which one do you prefer?
Okay, let's go with the one we have both not seen too much, the Rick and Morty.
Okay, cool. So basically what we can do is this API, let's do a curl just to see what it does. If we do a curl of this one, sorry, let's use AQ. It gives us, like, these are the three things that we can look at. For instance, episodes, locations, and characters. Let's see, for instance, episodes, right? So we can do /episodes and let's see what we get. Ooh, there is nothing here. So maybe they did not implement this one. Okay, let's try characters. No, maybe I'm doing something wrong. Maybe they want a slash.
Should we?
Oh, it's character singular.
Character.
Okay, that works. And was it locations? Location. Okay, that was singular.
All singular. An episode should be episode, I guess.
Episode, let's see. Yeah.
Episode. Okay.
Okay, the interesting thing is that, let's see. I want to go to the top. Let's do this. Let's do this. So basically, the interesting thing is that we have two main properties. The first one is info, and then we have results. Inside info is telling us, okay, for this specific request, there are 41 pages. Sorry, there are 41 elements, so it means there are 41 episodes, and they are divided in 3 pages. So this is just the first page. If you want to get the next one, this is the URL you need to call, which is basically the same URL with page 2 as a query string parameter. So you can already imagine, okay, if we want to visit all the pages, we need to do the first request, then take all the data from results, then we read this value associated to this next key. We can call that URL, we'll get the second page, and we keep going until next is going to be null. Right? Mm-hmm. Wouldn't it be nice if we could do for of all the pages and do a console log of all the episodes or all the characters or whatever?
That's magic.
Yeah, it would be nice, right? But if we try to do that, of course, it doesn't work because we are doing async, and for of is synchronous, so it's not gonna wait for us to complete the HTTP request. But we can make that happen because thankfully there is an equivalent of the Iterator and Iterable protocol for async iteration and async iterables. And let's discuss that. So an example that we can do is the same countdown thing, but we can make it asynchronous, meaning that the countdown is actually wait 1 second between one element and another. So that kind of simulates that we are doing, I don't know, an API request request or something like that. And this is just to explain the protocols. Then we can convert that logic into our actual API logic. So let's call it async on down, maybe. JS. So what do we want to do? We want to do exactly the same thing that we did before. So I'm going to copy all of this because I don't want to rewrite 17 lines of code. And let's say create async on down. But now, before returning here, we want to wait 1 second. Actually, let me see if I'm using Node 16.
I think you are.
Yeah, so in Node 16 there is a nice helper that I think is called const. I think it's called set timeout. Let's see if my memory is good. If not, we'll look it up. Require from timers slash. Is it just timers? No, promise or promises. Let's see if this works.
Okay.
And what this does is like a special version of set timeout, but instead of using a callback, you can just await. So it's easier here to say await set timeout 1000. So this is literally going to wait 1 second. Now, of course, we cannot use await here because this function is not async. So we want to put async here.
But you create async count and still have that quickly. Is it because it's not used yet? I think.
Oh, this one is complaining because it's not used yet. Yeah. So what we can do is to do const down equal create async on down from 5, and then we do console log countdown dot next, just to get one element out of it. And all of this for now, let's comment it because we're not really using it yet. So we are just trying to make an async iterator, right? So an async iterator, if you want to take the official definition, is literally an object that has a next method, and that next method returns a promise, and eventually when that promise resolves, it's going to give us an object that contains done and contains a value. So it's literally the same definition as before. The only difference is that rather than returning the object straight away when you call next, we return a promise, and that promise eventually is going to give us the object in the format that we expect. So that's the definition of what is an async iterator. Now, of course, if we do this, this is going to give us a promise, so it's not really useful. What we need to do is await this promise. And I think ESLint doesn't know that we can do await top level here. Let's see if it works. I'm not sure if you need to use ECMAScript modules, but let's see. We can try. Async come down. Yeah, it doesn't like it. So what we can do, let's see if I remember correctly. We can do type module, and then we can convert this one to import set timeout from, I think now Node.js will like the await. Let's see. Okay, didn't find the module. It's not called timers. Let's see, maybe it's timer.promise. No, let's search it. Let's search it.
I don't know. Okay. Timers.
Node.js timer module. Is it here? No, it's not there yet.
Maybe you should do timers / promises.
It is probably that, yes. Timers. This is node 16. Timers promises, and then there is set timeout, yeah. Let's see if this is the one. Okay, import set timeout from timers promises. So we got it super wrong.
Yeah.
That should be now correct.
Yeah.
Thank you.
Sure. And,
okay, so let's run it again. You can see that it takes a little bit of time, around 1 second, and then it shows us this value. So nothing particularly impressive yet. Of course, we can keep calling this multiple times, and we should see that it takes about 1 second between one element and another. Right, now the next question obviously is how do we make this an async iterable as well? And it's actually fairly easy. The only difference is that this is called async iterator. And we need a comma here. And now at this point, what we can do is use this for await, which is a special version of the for of, where we can say cost value of down and do console log of value. Let's see if that's good enough.
Okay.
Seems to be working. Let's see if it stops. Yeah, seems to be okay. Again, this is just ESLint. There is a way to configure it to understand that now you can do top level await. The alternative, if you're not using Node 16, what you can do is do like, I don't know, async function main, wrap all this thing, and then just call main. And when you do that, it's generally good practice to also do catch error and do console.error and process. What are you doing? Process.exit 1.
Yes.
So this is literally the same thing that you can do in, I think Node 14 maybe already supports top level await as well. But if you're using it, for instance, Node 12, I'm not sure it's supported. So if you're using older version of Node and you want to use await, just wrap it in an asynchronous function and call that function. So that should be literally the same stuff. Yeah. Okay, now, do you have any questions, first of all, on this stuff, or comments?
Yeah, it's pretty good. Like, all getting a lot. I'm really learning a lot here.
Yeah, and then, by the way, we are almost close to the end. So the only last things that we want to see is, of course, we can use generators here as well to make this super simpler. And I'm going to actually copy this one, gen, and maybe call it, I don't know, gen async. And what we want to do is, of course, have the same import that I'm going to copy paste, otherwise I'm going to get it wrong. And now we say that essentially the only thing we want to do is this. And then inside the loop, what we want to do is await set timeout of 1000. So what is interesting here is that a generator, or let's say a function, can be special in two ways. In one way, we already seen when you put the asterisk, it means this function is a generator. So you can use this special keyword called yield inside the body of the function. But we also know that a function can be also special when you put async in front of the keyword function. But we can also combine the two things. We can use async and the asterisk, and that is called an async generator. And inside an async generator, you can use both the await keyword and the yield keyword. And it's actually really interesting what JavaScript is going to do with this function. So basically what it's going to do is, because it's async, it's going to give you an object that every time you call .next, is going to give you a promise. And then that promise is going to resolve to the value that is the first time you find yield. The next time you call next is going to remember that you were here, is going to resume from there, is going to give you another promise, and then that promise is going to resolve the next time you go again all around the iteration and you get here again. So it's kind of combining the two features of async and generator. So there is a lot of magic going on there. But if you understand this magic, again, we are doing something in about 5 lines or 6 lines that here we were doing in what? 20 lines. Here we are doing it in 8 lines. So it's, again, another syntactic sugar that you need to understand all the magic that is happening behind it. But when you understand it, it can actually give you code that is much shorter, easier to write. And if you know these concepts, it is also easier to read. So now if we run this code, it should give us exactly the same result as this one. So if we do node, async, sorry, we call it gen async, I think, yeah. Ooh, no, it did fail because we forgot to say for await, right? So here it's saying countdown is not iterable. And in fact, it's not, because it's not implementing it's not implementing what we had here, which is symbol.iterator, but it's implementing symbol.async iterator. So if we do this, now we should try to see, is it an async iterable? It is, and it's running the code. Okay, so what do you think? Can we use this learning to do our own API stuff?
Yeah, I think we can.
Okay, so let's say, let's call it rickmorty.js. I think I'm going to install Axios, or do you have any other preference for an HTTP client?
Node fetch.
What do you generally use?
Generally, I use node fetch.
Okay, let's use node fetch. I just don't remember the...
Yeah,
so you're going to help me out with doing a request. Is it just node fetch?
Yeah.
Okay, so how do we import? So import fetch from node fetch.
Well, I normally use the common JS syntax, but let's see, that should work as well.
Okay, so we can do a console log of fetch just to be sure that we are on the right path. Yeah, that seems to work.
Yeah, that works as well.
All right, so we want to do async generator just because we know it's just a nicer shortcut, right? So we say async function asterisk, and let's call it characters. Right, we want to get all the characters one by one. And then inside this function, we need to do the first request. So we want to do, I suppose, let's just say for now, const page 1. It's equal await fetch.
Yeah, just passing the URL. And
Pass the URL, which we need to copy from here. So this guy, and then it's character, singular. Character. And then do you need to do...
No.
Wait, this one will be result, I think, if I remember fetch correctly.
Yeah, then you have to do result.json to get like the JSON payload. Yeah, result.
And you need to await that as well, right?
Yeah, yes.
And then let's just do for now a console log of data. Okay, so actually let's do a yield of this data because this is an async generator. Now what we want to do is characters, let's say make characters paginator. Terrible name, but it should be explicit.
It works.
So let's say characters, right? Equal make this. And now what we want to do is just do a console log of await characters.next.
Let's see the
We should see this data here, right?
Yep. Let's see that.
Let's see if we did. Okay, it's kind of working. So it's giving us value and results. Now I want to actually, let's do this. Let's do const data equal this. And I want to do data.results just to understand what's the structure there. Ooh.
Results.
Results.
No, value. Value first, I guess.
Oh, you're right. There is a value and then results. Yeah, good catch. Value.results. Perfect. So for every character, we have a name, and if it's alive or dead, I suppose, what is the species, the type, gender, whatever. Let's say that we just want to print the name. That's probably the easiest. What we could do would be for, let's say, name, const, name of, actually, let's say character of this. We want to do console log of the name. No, sorry, character.name. You can tell that it's Friday and I'm tired.
Yes.
Okay, so we are getting all the characters, but this is only page 1, right? So what we want to do next is keep calling the next page. So ideally what we could do is for await const page of characters, right? This should print every single page. It doesn't like that because it doesn't like await, and we don't need to call next anymore, right? And now here we have for page.value.result, right? Make sense?
Yeah, it does make sense.
So basically we are saying for every single page, and we need to await pages because they are asynchronous, they are HTTP requests. In a page, we know we have a list of characters inside this page.value.results, and then we print every single character. So now we should get exactly the same response because we didn't really implement going to the next page. We still have only one page, but let's see if this works. Doesn't work. So what did we do wrong?
Cannot read results of undefined.
Oh yeah, of course, because value is not there anymore. Value is what we were getting from the generator.
Yes.
That from the iterator version of the generator, because we were calling .next. So now, yeah, that works. Okay, so now what do we do here to go to the next page? A simple thing could be to do this. So to do the same thing here, but instead of using this URL, what we can do fetch is data.info. Let's see, sorry. We should have it somewhere there.
I think it's .info.next.
I think as well, let's double check. Yeah, .info.next. So what we can do is do data.info.next. And then we can do again yield data. Right? Of course, result, we need to, let's do let for now. And this guy. And data, let's do let. And remove this guy. So now we should be able to get 2 pages, right? So if we run this again, we see a lot more characters. So it's doing, actually, let's do here console log of dash 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 just to see where a page is finishing. Oh, sorry, not here, but in the outside one. So we can see that we have 2 pages. This is the first page, and this is the second page. Of course, we can keep doing this, but we want to make it like generic, right?
Yeah.
So one way that we can make it generic is to do let result and data, I suppose. And then what we can do, probably we can do a do while. Let's see if we can make it work. While, and we say data.info.next. So until we have data.info.next, it means that there is another page to get. And then we can probably copy all of this inside here. But we need a way to define the first data.info.next. So one thing that we could do is also do let URL and do this. And then here we're going to just use URL, but we also need to reset the URL every time. And we should be able to remove all of this. Does it make sense what's going on here?
Yes, it does. So
I don't know if you ever use do while.
Yeah.
It's not super common.
Yes, but so my understanding of the do while is it's going to execute the loop at least once, even if so even if there's no next, it's still going to run the first.
Exactly. So the first time is going to use this URL.
Yeah.
So the first time is going to do one request.
Okay.
It's going to get the data. It's going to prepare the next URL. Actually, here we can just do while URL, right? So this is going to be okay. Let's be more semantic. Let's just call it next URL. This is next URL, next URL. So we are saying do this thing, and then check if you need to do it again. So you keep doing it while there is a next URL. So until like next URL is not null, you keep going.
Okay.
Now, hopefully we did everything correctly. Let's see. No, of course, because fetch needs to use next URL.
Yes, I didn't catch that.
Right, so that seems to be working.
Oh my God, this is
so many characters in this series. I think there were like 43 pages.
Yeah.
Let's do a console log of data info, just because I'm curious to see how many pages there are. Yeah, 34 pages. So it's going, you see that the increments the next URL up to 33.
Wow.
So page, why is 33 and on 34? But it seems correct because here we have less characters, so probably this page is not complete.
Yeah, I think.
Okay.
Yeah.
So maybe pages start from 0. So you have a page 0, then page 1, and so on.
Okay, yeah, that's true. Okay, well, the first call didn't have a page, like the first character. So
so maybe by default is page equals 0.
Yeah, doesn't happen. So that works. Wow, this is super handy. Like I could. So okay, are you done with the implementation?
Yeah.
Or you still want to tweak it? Wow.
I think that's it. That's all I had for today. I don't know if you have questions. We can try other things, but this is pretty much what I wanted to do.
Yeah, I think we've maxed out our time. But I just want to know, okay, in your work, do you is there this special case where you reach out for making your own custom iterators or iterable?
Mm-hmm.
Yeah. So
that's
like
a good question.
Yeah.
So I had few use cases that maybe are not super common, but I'm gonna try to describe them anyway.
Okay.
And then I'm gonna provide use cases that are maybe a little bit more common. So basically, I was working with a company that was doing network security, and we were building a product that was able to find certain patterns in the network traffic and decide, oh, this looks like an attack, or maybe something else dangerous like a virus or other type of automated malwares or things like that. And I was writing like a testing framework that needed to simulate a bunch of different scenarios and needed to simulate them dynamically, so with random values or pseudo-random values.
Okay.
And it was built in such a way that, for instance, you could say, okay, simulate that now there is a new device in the system. And then you can say, okay, now create a connection between two devices, things like that. Then you can say, okay, now create a HTTP call between one device and another. And it was very useful implementing all of that using generators, because with generators, you could keep the state. And every time somebody was calling, generate a new thing, I could check, okay, let's see what other things are there. I'm going to create an ID that's unique. I'm going to take decisions whether, I don't know, the type of this new device is going to be different from the others. So it was just convenient to use generators because you could abstract some of that logic away.
Oh, nice.
So that was kind of a weird use case. I don't think it's super common. More common use cases are, for instance, when you need to do, I don't know, get some data from a database, maybe because you want to do conversion from one database to another, and maybe you need to get all the data manipulated somehow and put it in another database. So something like a migration maybe of databases would be useful. Another use case which is really interesting, I like Node.js streams a lot. That's another thing that I always talk about. But Node.js readable streams are also async iterators. So you can use that nice for-await syntax to consume all the data from a stream. So that's very convenient. For instance, if you just need to process, I don't know, a CSV file line by line, there is a CSV library that will give you streams, and you will get one line at a time. You can just do for-await of every single line. And that can be very useful when you just want to do some super quick filter or super quick search or conversion of the data. So yeah, I think that, I hope that answers the question at least.
Yeah, that answers it completely. So I'm pretty sure, like, I'm going to really play with this, because I think I've just got like an exclusive access from a guru in async and iterators and iterable, and I'm just wild at the possibilities. Just gonna set this up again. Okay, so thank you very, very much for taking time. I know it's Friday, like I'm still into your rest time, but thank you for doing this, for coming to teach me on this session. I really, really do appreciate it. And yeah, any words you want to share with us? Anything?
Yeah, no, I just want to say thank you, because it's a pleasure for me. So I'm happy that, I mean, I was invited, so thank you for inviting me.
Yeah, sure. So, yes, and where could we reach out to you? So maybe if someone watched this video sometime and they want to like ask some questions, where could we get you?
Yeah, so you can find me on Twitter. I think is the place where I am most active. The username is Loige, Loige, and I think probably you'll put the link in the description or something like that.
Sure. Yeah,
but also you can find me on LinkedIn, so whatever you prefer. And I also have a blog, so I'll make sure you get all the links.
Yeah, sure. I'm going to add that to the YouTube description where I'm uploading it. So thank you. So so there you go. That's the very first Kevin Your Thing session. Like, I just have this. I think I understand iterators and iterable better, like even JavaScript better, and I also learned some of his some of his pipes he could use with call. I didn't know of the JQ, so I picked that up. So it's really good, and I thank you, Luciano.
Yeah, thank you very much for having me. Bye, everyone.